An alternative solution to the rectangular hyperbola arch problem is that we can put the base of the hyperbola along the x-axis and make the origin in the middle of the base. So 0, 0, that black dot represents the origin, which then makes the coordinate, the position of the vertex at 0, 30 along the y-axis, and then a further a units up to the center, which is marked in green. So the coordinates of that center is going to be at 0, 30 plus a. So although we don't know exactly where it is, we know where it is in terms of a. We also know this fixed coordinate of 60 and 0, which is that red dot, and we're going to use that to solve for our a value. So how do we set this up? Well, we need to put it into the equation of the rectangular hyperbola form. So it's going to be x squared minus y minus, well, we need the horizontal shift, which is going, or sorry, the vertical shift, which is going to be 30 plus a. And then that all squared is going to be equal to, since it's a trans y, it's going to be equal to negative a squared. So I've established the equation. To solve for a, I just need to plug in a known coordinate. I'm going to use 60 and 0. I could possibly use 30 and 0. However, if I do that, what I'm going to end up with is negative a squared equals negative a squared, which isn't particularly useful. So we want to use that 60 and 0 coordinate. So plugging that in, I'm going to end up with x squared minus y minus the 30 plus a. And that's going to be all squared equals negative a squared. And in here, I'm going to plug in x is 0, sorry, x is 60, and y is 0. Okay, so when I expand this all out, we end up with 3,600 minus, well, this is going to be negative a minus 30 squared equals negative a squared. Okay, so that's 3,600. When I expand that bracket out, I end up with a squared plus 60a plus 900 equals negative a squared. The negative a squareds are going to cancel out here. So I get 3,600 minus a squared minus 60a minus 900. That's equal to negative a squared. Cancel those out. Combine my like terms. So this is 2,700 on this side and negative 60. So I go add 60 to both sides. And then solving for a, I end up with 2,700 over 60. And that will simplify to, well, if I do 2,700 divided by 60, I end up with exactly 45. So a is equal to 45, which then solves for the equation of that hyperbola. So for part A, I'm going to end up with x squared minus y minus, well, 30 plus a is going to end up being 75, so y minus 75. So the location of that green dot is going to be at 0, 75. And that's going to be equal to negative 45 squared. So there's my equation. For part B of this then, I'm just going to put a box around this. So that's part A. For part B of this problem, what we want to do is we want to find the location of the x-coordinate when the arch is at 25 meters. So maybe somewhere around there. I want to know the x-coordinate here and here. Well, to do that, we know that y is equal to 25. So we're just going to plug that into my equation and solve for x. So I end up with x squared minus, well, y is 25, Okay, so I'm going to expand this out. Well, I'm going to work this out. So x squared minus, this is going to be negative 50 squared is equal to negative of 45 squared. Okay, so x squared minus 2500 is equal to negative of 45 squared, and 45 squared is 2025. Okay, so that makes x squared equal to, when I add 2500 to both sides, I get positive 425. So the x coordinate is going to be plus minus the square root of 475. And that works out to approximately, what is that going to be? Square root of 475 is approximately 21.79. Okay, so at plus minus 21.79 meters, here and here, we're going to have a y coordinate height of 25 meters.